In this episode, solving linear equations with variables on both sides. Coming up, back into action, episode 1. Hey guys, today I will show you how to solve linear equations with variables on both sides. And before we get started, I have separate video on basic kinds, how to solve basic linear equations, and the link will be down below in the description box. Now, suppose you have been given something like this and you need to solve this equation for x. And by the way, what does it mean? Well, all you need to do is just find the value of x, the solution of your equation, or sometimes it says a root, that satisfies your equation, that makes your equation true, that works for your equation, if you will. So all that means is when you substitute your value, your actual number, let's put it into this perspective, instead of x in your equation, everywhere x appears. So in this case, x appears twice. So when you substitute, when you plug in that value of x, that actual number, instead of x, that your equation becomes true. Well, as a good rule of thumb, since your variable x appears on both sides of your equation, as a good rule of thumb, you want to bring and collect your x terms together. And again, the way you would do is just do the opposites. Keep in mind that subtraction undoes addition, and vice versa. Multiplication undoes division, and vice versa. So you are going to do these opposites in order to move terms around and collect like terms. So we want to bring this 2x to the left side. So since 2x happens to be positive, you want to subtract 2x from both sides of your equation. Remember, you can subtract, add, multiply, divide your equation as long as you do it to both sides, so keep it balanced. Also, I want to move this 3 to the right side. So say we want to collect x terms on the left side and your constants, your numbers on the right side. So I want to move this 3 to the right side. So again, I would do the opposite. Since subtraction is the opposite of addition, I want to subtract this 3 from both sides of your equation. Now, in the next line of your work, 5x minus 2x gives you 3x. 3 and 3 cancels each other out, it goes away. Drop down the equality sign at this point. 2x and 2x gone. Minus 9 minus 3 gives you negative 12. And finally, the last step, I want to isolate my x. So I want to get x alone. So since we have these 3 attached, your x, so divide both sides of your equation by this coefficient 3. So 3 goes away, 3 drops out. So you would be left with x equals 3 goes into 12 4 times, and you keep this negative sign. So your answer is negative 4. So that's your solution. That's your actual root for that equation. All right. A quick side note. So at this point, you could check your out by just taking this negative 4, as I said before, and you plug it in for x twice. Insert it for x everywhere x appears in your problem. So you could do it mentally, you don't have to write it explicitly. So 5 times negative 4 becomes negative 20 plus 3 gives you negative 17. So on the left side, it's negative 17. Let's check it out. Does it equal to the right side? 2 times negative 4 gives you negative 8, and negative 8 minus negative 9 gives you negative 17. As you can see, negative 17 is precisely the same as a negative, so negative 17 is the same thing. So that's true, and that means your value checks out and it does work for your equation. Moving on. Suppose you have been given something like this, the same idea. So you want to collect, as a good rule of thumb, your x terms on the one side. Basically doesn't matter on which side, by the way, and I will get back to this in a while. And you want to collect your actual numbers, your constant, on the other side of your equation. Now, since this negative x happens to be negative with this negative in front of this, I want to move my x term to the right side this time. Well, you can move 11x to the left side like I did before, but you would get something like a negative term. Negative x and negative 11x gives you negative 12x. So I want to avoid this. Again, you could do that way, but I wanted to avoid negatives, and the way you would do, I would just kind of swap the order. So I'm going to move this negative x to the right side by adding x to both sides of your equation. So we do the opposite, and on the left side x goes away, x disappeared. And I'm going to move the constant, this number, negative 31, to the left side by adding this 31 to both sides of your equation. Now, negative 7 plus 31 gives you negative 24. Drops down the equality sign, so this x, we could simply ignore it at this point, it goes away, it disappeared. 11x plus x gives you 12x, and this negative 31 cancels 31, drops out. And finally the last step, so I want to get my x alone. Whatever attach your x, so in this case it's 12, divide through, so divide by 12 both sides of your equation. So 12 cancels itself over here, and you would be left with x equals, I'm going to change the order, since 12 goes into 24 twice, and you have to keep this negative, so be aware of this negative. So you end up getting x equals negative 2. And that's your solution, that's your root for that equation. So that works, and that's true. Again, at this point, if you would like, you could check it out by taking this negative 2 and plug it in back into your original equation twice in 2 places and see if it works. Alright, I hope it has been helpful to you. Thanks for watching and train your brain. I know everyone hates math, but if you like my video, please hit like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't before, to do not to miss my new